Cone-shaped tank has a cross-sectional area that increases with its depth. Okay. So that's the H, I guess. I guess they're saying that the area at H is pi r squared, H squared over H cubed. So that would mean at H, it would be pi r squared over H. That's a little bit weird, isn't it? Um, um, hmm, kind of weird. Kind of weird. Okay. Show that the work to empty it is half the work for a cylinder with the same height and base. Okay, so the work would be the integration from 0 to h pi r squared h squared over h cubed dh times rho. So that would be rho pi over h cubed, 0 to h cubed. The r squared comes out as well. dh. So that's h over 4. Rho r squared pi h cubed times 4 h4. So that's a quarter pi rho h squared or. Now for the cylinder, that would be density again, 0 to h pi r squared h dh. So that would be a half pi rho r cubed h squared. Show that the work to empty it is half the work for a cylinder with the same height and base. I mean, that is half, but not for the RH part though. Wait, why did I write cubed here actually? It's still squared. Hmm. H cubed. I mean, I really think that should be a 2. It's so wrong, I think, for it to be a cube. Like, look at the units. Let's see if the units are right. The units would be r squared, which would be meter squared, over h squared, meter squared, and then h cubed, which would be meters cubed. So that would be 1 over meter cubed. Oh, sorry, and I forgot this h. Sorry, so that's another meter squared. So meter squared, meter squared. Hang on. I'm a bit tired. Meter squared, meter cubed. So that would be meters. But if that was a square, then we'd get meter squared. So the units are definitely wrong here. That should be a 2, I think. If that was a 2, that's a 2. That's a 2. That's a 2. So that would be a 2. And that would be half of a half pi rho r squared h squared. So I really think there's a typo in that question.